Hello students, how are you? How you are keeping yourself? I hope and I pray to God that you are well and safe at your home. As far as the chemistry is concerned, today we will discuss about the VSEPR, valence shell electron pair repulsion theory, one of the most important theory regarding the structure of molecules. So how these molecules look like? In the covalent bond, what is the structure of molecule and bond angle and some or other parameters that we will discuss in this unit, VSEPR and structure of molecules. So let's start and study the VSEPR, valence shell electron pair repulsion theory. So students, in today's session we shall discuss about the valence shell electron pair repulsion theory. In short, it is also called as VSEPR. Students, in my opinion, this is the backbone of the entire chemical bonding chapter. In the chemical bonding, whenever, wherever you will say or you will discuss about the shape, the name will come in front of you will be VSEPR, because VSEPR theory is the only one by which we decide the shape of molecules. Examiner used to ask questions about the shape of molecule. He keep on asking questions about the shape of molecules. So molecules have different kind of shape, like what you see in this picture is the bent shape. This structure looks like there is a bent, angular. You can also call this angular shape or bent shape, or you can also call this as a V shape. This species is linear, in the linear fashion. This is triangular or the trigonal. Planar means one plane. It is two-dimensional structure, not three-dimensional. Another one is tetrahedral. This structure, if you adjoin the apex of these bonds with each other, you will see a tetrahedral structure, in which, you know, tetrahedral means, what is the meaning of this word? Tetrahedral mean four face. In this molecule there are four different faces. Another one is the square bipyramidal. I just told you, also called as octahedral. Now you must be thinking, what is octahedral? Octahedral means in this structure 8 faces are there. You see, if this bond is joined with these 4 points and they are also with one another, then there is a formation of one pyramid, and this exactly same pyramid, one more another pyramid will form below. So this structure is octahedral structure or the square bipyramidal structure. Alright. How do we determine the shape of these molecules? There are certain factors which are responsible for the determining the shape of molecule. Out of these factors, the number one is VSEPR. The number of bonded and non-bonded pairs, they play a role here. In the VSEPR concept, it is very simple concept. If you will concentrate, you would be able to understand this principle in a single time. See, what happens with the hybrid molecules? In the hybrid molecules, there are some orbitals which repel each other. When they repel each other, the repulsion between them, because electrons are present in the hybrid or unhybrid orbitals, these electrons, as per their nature, they repel each other. What will happen when they will repel each other? When electron will repel each other, obviously energy of the system will increase. Eventually it will increase the energy of system. When there will be increase in the energy of system, if energy of system will increase, stability will decrease, stability will go down. So in order to maintain the stability of compound, central atom arrange the outer electron pairs, when I say electron pairs, I mean to say bond pair and lone pair as well. So the central atom, they arrange electron pair around themselves in such a way so that repulsion between them can be minimized, and during this attempt of the minimum repulsion they attain some geometry called as hybridization and shape of the molecule. So this we will discuss in this unit, VSEPR theory. The very name of this theory explains the concepts which are explained by this theory. VSEPR, valence shell electron pair repulsion theory. So the theory was proposed by two scientists, 𝕍𝕀𝔻𝔼𝕆 and 𝕃𝕀ℎ𝔼, which are pictured here, and this theory was further developed by another two scientists, 𝕆𝕋 and 𝔼𝕆 in 1957. Initially it was given in 1940 and it was later modified after 17 years, right? So what are the features of this theory? This theory says shape of the molecule depends upon the repulsive interaction. Means there is always a repulsion between electrons of the species. Because of this repulsion, molecule attains a geometry. So the shape of molecule somehow also depends upon the interaction between them, right? Now among the valence shell electron pair, there are two types of electron pairs. One is the bond pair, in short we will call it as BP, and another one is the lone pair. Lone pair here we will call it as LP. BP is the pair of electron which is already engaged in the bond formation, while lone pair LP is the pair of electron. Again it is a pair of electron, but it is not engaged somewhere. It is not engaged anywhere in the bond formation. It is just placed over the central atom, right? Now being similarly charged, the electron pair of the molecule in the valence shell, whether it is lone pair or the bond pair. See, bond pair is also electron. In the end of day, it is a pair of electron, and lone pair is also a pair of electron. In the end of day, it is also a pair of electron. So what do you expect when these electron pair, when they meet with each other? What do you expect? What you are expecting, students? Will they attract each other? No. Nevertheless, they will not attract each other. Being the similarly charged, they are supposed to repel each other, and yes, they will repel each other. And because of this repulsion, what will happen as a result? Due to the repulsive forces, these electron pairs tend to occupy a position farthest from one another. Why farthest from one another? So that repulsion could be minimized in order to create minimum repulsion and maximum stability. And here multiple bond is treated if it is a single bond in the VSEPR, and 2 or 3 electron pairs of multiple bond are treated as the single super pair. Please remember this name. This is important. Examiner might ask you a question in the 11th examination. What do you mean by single super pair? So VSEPR model is applicable to any structure where 2 or more than 2 resonating structures are found, and simple structure of the compound is failed to explain all the properties of the compound. Such hybridizations we will explain here. Alright. So what are the next example? In the VSEPR theory, what happens in the VSEPR theory? See, this yellow color is the lone pair. This is also another lone pair. And this one is bond pair. So what kind of repulsion is there between them? Is the bond pair repulsion. And what kind of repulsion is there between them and them? It is lone pair repulsion. And the moderate repulsion, lesser than lone pair and greater than bond pair is the lone pair bond pair repulsion. So there are not necessarily, there are 3 possible force of attraction or repulsion in the molecule: bond pair, lone pair, and lone pair bond pair. We will also study the relative stability or the relative strength of these repulsions. So the strongest repulsion is lone pair, between lone pair, then it comes lone pair and bond pair, and believe me students, the weakest force of attraction which could exist is bond pair bond pair. So this is the bond pair and bond pair, which simply means there is a formation of one bond and another bond. Alright, so this is bond pair and bond pair repulsion. Now, to apply the VSEPR theory, we first divide the molecule in two basic categories. So first category of the molecule is those in which there are no lone pair of electron in the central atom. No lone pair. All electrons are paired. Or the second category is molecule in which central atom has either one or more than one lone pair of electron. Now it is very interesting to see that how these lone pair they placed themselves. So shape of molecule, it's a definite relative arrangement of bonded atoms in the molecule, which is called as the shape or sometimes geometry. Although technically shape and geometry, they are two different words, but in this unit we consider them as an very equivalent to each other, although they are different. Shape and geometry. Shape is something else and geometry is something else. Alright, geometry belongs to the hybridization. Say for example, hybridization is sp3, then no matters what the shape of another species is, but its geometry will be tetrahedral, and each molecule has a definite geometry which is accounted for the minimum energy, which is in the order to attain the state of minimum energy. So they are done in the accounting of minimum energy. There are repulsive interaction also between the electron pair of one species and the electron pair of another species, and this is a force of attraction. Alright, now if the repulsive interaction between the electron pairs are not of equal magnitude, if all the bonds not of equal magnitude, what will happen? Now you please try to understand this with this example. There are three arrows. There are three arrows, or you can say there are three vectors. These vectors, they are situated far apart from each other with a one bond. So if the repulsive interaction between the electron pairs are of equal magnitude, geometry of the molecule is said to be regular, which means if lone pair is not there, only one kind of repulsion is there, which is bond pair and bond pair. This is called as regular geometry. Each hybridization, no matters, you have a few different examples of hybridization, so no matters what kind of hybridization you are talking about, it has some shape in which lone pairs are not present, called as regular geometry. Alright, so these are some shapes of the molecule. Here is the one in which central atoms is bonded with a pair of electron only, right? And here in this, central atom is bonded with the pair of electron and also bonded with the lone pair of electron. Now I think you already know what is lone pair. How many times I have to repeat this word lone pair? It is now common, very common for you. Everyone knows lone pair is the pair of electron which never participate in the bond formation. So here are some examples in which only bond pair is there and there is no lone pair. Please remember, please take note of that, there are no lone pairs. Those species which are there in front of you, they have no lone pairs. All the electrons are bonded. First example is AB2. You see, in the AB2, shape is linear, bond angle is 180 degree. Examples BeCl2, CO2 and C2H2 we discussed few minutes back, and these are the examples of sp hybridization with the bond angle of 180 degree. This is the real example of sp hybridization. BeCl2, two bond pair of electron in BeCl2, they repel each other and they are arranged at the angle of 180 degree. Alright, which is the repulsion between the electron pair of valence shell. In the molecule AB3, Now we don't have 2 bonds. Now we have 3 bonds. And when we will try to arrange these 3 bonds, you can arrange them in the plane. So you don't need to form a 3-dimensional structure, because again sp2 hybridization, in which molecule type is AB3, is triangular planar structure with the bond angle of 120 degree. Example is BF3. BF3 is very common example of this. It has 3 bond pair of electron, makes an angle of 120 degree and trigonal planar shape, one plane, 2 dimension. Another is AB4. AB4 happens in tetrahedral. How many electron pair? 4 electron pairs. What kind of electron pairs? 4 out of 4 are bond pair and 0 is lone pair. So here in the sp3 hybridization, molecule type AB4, where no side atom is there, just the product. Alright, and shape is tetrahedral. This is the central atom and these are 4 side atoms if you are talking about the CH4. And again, like I said, if you adjoin center of these, you will get a tetrahedral. Means tetra means 4, hedral means face, 4 face structure you will see here. Another example of this VSEPR is CH4. In the CH4, bond angle is 109 degree, tetrahedral shape, all bonds are identical. So 4 bond pairs of electron present around the carbon atom in CH4, they repel each other and move apart to give the molecule a tetrahedral shape. And this is how we get the tetrahedral shape. Then molecule AB5. In the molecule AB5, there is a formation of 5 bonds, and these 5 bonds, they arrange themselves in like same exactly like in this picture. These 3 bonds which are at the apex of a triangle, they remain in one plane, and there is another bond which is above plane and there is another bond which is below plane. So now this shape is not 2-dimensional anymore. Now this becomes 3-dimensional shape. Alright, please have a look. Bond angle is 90 degree and 120 degree. Examples are PCl5 and SbCl5. Here is the PCl5, 5 electrons pair, which is bond pair, are arranged around this phosphorus atom, and bond angles, you can say in more clear picture, it looks like this. What are these 2 bonds called? They are called as axial bond, and these 3 bonds are equatorial, right? So it acquires a trigonal bipyramidal shape, which is also pyramidal shape, right? In the AB6 molecule, shape is octahedral. Octahedral means 8 faces. Like I said, tetrahedral means 4 faces. Similarly, octahedral means 8 faces. Here in this example, all bonds are of 90 degree. The real life example is SF6. Now you see, you please try to adjoin the centers. What picture you see here is the square. Now if you join this atom with these 4, now you will get a pyramid like structure, and the same pyramid is there below the plane. So it is a square which is in the plane, and bipyramidal, one pyramid is above and one pyramid is below, and this structure is also called as octahedral structure. 8 faces. The structure with the 8 faces is octahedral structure. SF6 is the real life example of this structure. You see. Now you see in the SF6 it looks like this. Let me draw it again. These are 4 fluorines situated in the plane. One fluorine goes above the plane and one goes below the plane. if you join this with all others, see students, you will see 4 faces. 1, 2, and 2 are in front of us. 3, and then 1 is on another side, 4. So 4 faces here and 4 faces below. There is a formation of 8 faces. Remember, alright. This SF6 molecule acquires an octahedral shape to have minimum repulsion between the bond pair of electron, because in the octahedral shape repulsion is minimized. So here is the tabular form, some examples and arrangements you see for the quick last revision. When the central atom has a bond pair as well as lone pair of electron, these are the examples of molecule AB2E, AB3E, A4B, AB4E means 4 bond pair, 1 lone pair. This E denotes lone pair, right? And B denotes simple bond pair. So where A and B are the different atoms of a molecule and E represents the number of lone pair. Suppose you see any species in which 3 lone pairs are there, so you will represent as E3, because 3 lone pairs are there, so you will represent this as E3. Alright. In the molecule AB2E, this is the shape, trigonal planar, and if 1 lone pair is there, this is 3 plus 0, no lone pair, and 1 lone pair is there. If 1 lone pair is there, it is band shape. It is the band shape, angular. Another example, tetrahedral, 4 plus 0. This is also triangular pyramidal, but 3 plus 1. So this structure is called as trigonal pyramidal. Trigonal pyramidal structure. Alright. Example is ammonia with a bond angle of 107 degree. Ammonia, it also looks like pyramid, and apex of each pyramid possess hydrogen here, hydrogen here, and hydrogen here. This shape is trigonal pyramidal. 1 pyramid could be formed. In NH3, actual shape is trigonal pyramidal and the bond angle is 107 degrees. This is very important, students. This is something very important. Hybridization and bond angle. Please have a look. Then in this molecule type AB4E, you understand what is the meaning of AB4E? Means 1 lone pair is there. This E represents lone pair and this B represents ligands. This is trigonal bipyramidal shape, and this is seesaw. When 1 lone pair is there, it is seesaw, or you can say it is pie shape. If you turn it a little bit, you will see a letter of the English of the mathematics like pi, right? AB5E. What is AB5E? A has 5 bond pairs with the B and 1 lone pair like E. We know that lone pair never participate in the production of geometry. So without this lone pair, shape is called as square pyramidal. Means pyramid is there and which is in the form of square, right? Then another is molecule type AB2E2. In the AB2E2, 4 electron pair are there, but out of these 4, 2 are lone pair and 2 are bond pair. Lone pair and bond pair. If you do not consider lone pair in the production of geometry, it will be band shape. And the example is H2O. Another example is AB3E2, means 3 bond pairs are there and 2 lone pairs are there. the shape will be T shape in the sp3 dehybridization. Shape is T shape. Another is where 4 atoms are bonded with sigma bond and there are 2 lone pairs. These 2 lone pairs, they will arrange themselves above the plane and below the plane. When they will arrange themselves above the plane and below the plane, this shape will be called as square planar shape, two-dimensional. And there are few more examples of the hybridization like sp3 d3 hybridization, which we will discuss in the further coming classes. I hope you liked today's lecture. In the coming classes, we will discuss more about the hybridization, about the VSEPR and shape and geometry of them. Till then, keep coming and keep studying. We shall discuss about those in the coming lectures. Thank you so much for watching our classes. Keep watching and keep coming.